This is the one, right? So for 46, it says the ball rolls horizontally with a speed of, didn't I do that one already? No, I did 44. Yeah, it's similar. Off of a tall platform, if the ball lands 8.7 meters from the point of the ground directly below the edge of the platform, what is the height of the platform? Okay, so I'm going to draw my picture first, right? So the ball rolls here. Let's do this. The ball rolls off of the platform. So this is the ball. What was that velocity? 7.6 meters per second, right? And it lands 8.7 meters away from the platform. So this ball is here, okay, and it's horizontal is 7.6 meters per second, and so we'll say that it lands 8.7 meters away. All right. Okay. So this is different, and then the question is what is the height? Right? That's what they wanted to know. How tall is the platform? What do you guys think we should do? We have some information. Let's label some of the information and see what we have. What would you call the 8.7 meters? The distance, but how do we say that in physics class? Yeah, displacement or delta x, right? What are they looking for? The height of the platform, what is that? Delta y. So that's what we're looking for, is delta y. All right. What is 7.6? It's the velocity, right? In which direction? X direction. So it's the initial velocity in the x direction. What's the final velocity in the x direction? In the x direction. Yeah, it's the same thing, right? Same thing, because there's nothing acting upon it in the x direction. What do we need? What do we need to know? We need to know delta y. Well, let's start with delta y. What kind of equation would I need for delta y to solve that? Is there any other, wait, before we find the equation, is there any other information that I know about this problem that I haven't listed yet? Is there any information, any velocity, position, anything like that that I need to know?
Time.
Time, I need to know the time.
Acceleration.
Acceleration in which direction? Well, the acceleration in the x direction is 0, right? And if it's 0 in the x direction, do we have acceleration in the y direction? What is it? How do we know that? It's the acceleration due to gravity. Very good. 9.8. So the acceleration in the y direction, okay, that's good. Oh, and then somebody said an equation for delta y. All right, so one equation I can use for delta y, I think, would be, couldn't I use this one for delta y? Y equals Vy naught times t minus, or no, wait, plus 1/2 times the acceleration due to gravity times time squared. And as somebody already pointed out, we're not quite sure what time is yet. So I need to find time. Do we know the initial velocity in the y direction? The instant this leaves the platform, what is the velocity in the y direction? 0. Good. So Vy naught is equal to 0. So what does this whole term become?
Nothing.
Nothing. So I can find delta y. I just need to know one thing. The time. I just need to know the time. If I figure out what the time is, I'll plug it in right here and square it. How do I find the time? I got a lot of information about the x direction. Maybe there's a different equation I can use for delta x. What did we say delta x was? How do we calculate delta x? What was that example Father Jim used with us? I'm in a car, I drive for 30 miles per hour at 2 hours. How far did I go?
60 miles.
How'd you guys get that number? The what? The distance is equal to what? What's 30 miles per hour?
You get 30 miles every hour.
Yeah, but what is it? Is that a time? Is that a displacement? Or is that a velocity? That's a velocity. And if I travel for 2 hours, what is that? Is that a time, displacement, or velocity? A time. We said that 30 times 2 is 60, which is the displacement. So what you're saying is that the displacement in the x direction is equal to the velocity times time. But we don't know the time. Is that helpful or no?
Yeah,
Yeah, how?
because if you tried to make it equal to time, you would divide the delta x by the velocity.
Okay, so she said, yeah, let's do this. Let's rewrite that equation so we say that delta x is equal to the initial velocity in the x direction. Well, wait, don't we know these numbers? So couldn't I say 8.7 meters divided by 7.6 meters? Now where does that second go? Yeah, these will cancel and that second comes up on top. And so that's my time. So somebody get out their calculator and say 8.7 divided by 7.6. 1.14 seconds. So if I square that, will that give me the answer? Yeah, I have everything I need. So delta y then is equal to, what's 1/2 times 9.8 times 1.14 squared? I don't know, let's plug it in the calculator and see. So I'm going to say 1.14 squared times, now why did I do that first, guys? Please excuse my dear Aunt Sally, I always do the exponents first, right? Times 9.8 times, I'm going to say 0.5, we could do that. So 6.37 meters. Actually, we should probably say 6.4 meters. Let me check my fancy answer book. What question was that? Yeah. Now, there's only one little mistake that Mr. Adams forgot to write down, didn't I? What was the acceleration? Technically, it was in the negative direction, right? So this should have been negative 9.8, this should have been negative, and this should have been negative. Now, why would I have a negative 6.4 meters as a displacement? Because it fell down. So the negative represents the direction in which the object fell. Oh, Pretty good. You guys are smart.